So, hello, welcome everyone. I hope you're having an amazing time at the conference so far. So, the session today that we're holding right now is Let's Get Fired Up, getting started with Firebase Firestore. And our speaker is Navati Jain. Navati is an iOS developer at Loblaw Digital in Toronto, and she actively volunteers as an evangelist for the Women Who Code mobile um, track and as a woman tech maker ambassador and initiatives such as NS Coder Toronto, Apple's high school co-op program, and Canada Learning Code. So, in her spare time, she also indulges in writing poems or binge watching dramedy shows on Netflix. So, Nawati, back over to you.
Thank you so much. Just confirming that you can hear me, you can see my screen. All right.
Yep, everything's good.
Okay, great. So yeah, just yeah. Thank you so much for joining today's session, and I'm so excited to talk at this event at Connect Recharge. We're gonna learn what Firestore is. It's gonna be a jam-packed session, so let's get fired up. So my name is Navati, and I work as an iOS dev at Loblaw Digital in Toronto. And Loblaw Companies is a major retail grocery chain in Canada. And we create apps at Loblaw Digital to support our various banners and the pharmacy, the loyalty, online ordering, and our own clothing brand. And here you can see some of my handles, and I would love to connect with you folks. And we can talk about iOS, about TV shows, and even tea, which is, by the way, my favorite drink. And also, I'd love to talk about mental health and get your tips on how to keep my plants alive. So the plan is to look at what Firebase is and what services it provides. And then we'll do a quick comparison of the two database services that are there. There's Relational and NoSQL. And then we'll look at Firestore. We'll look at the key concepts and how to build a Firestore database. So you may have heard of Firebase, but I'll just walk you through it. So basically, Firebase is a platform that can support your app development journey in multiple ways. So if you're a front-end dev like me and you code for the web or for mobile apps, and you're focusing more on the front end, then you can use Firebase for a lot of the back-end tools, like things that you don't have expertise in, if it's like the cloud and database. But it's much more than that. It can also support server-side applications, and there are many other services that it can help with maintaining your app. And I'm going to show you a list in just a couple of slides. But yeah, fun fact, Firebase was an independent company and then got acquired by Google in 2014. So yeah, when you open Firebase, when you open the console, you see this nice, friendly, colorful web page. And as you can see on the left panel, there is a menu of the multiple services that Firebase offers. So there are a ton of services for building your app. So you can use the authentication SDKs to authenticate your app with providers like Google, Facebook, Twitter, just like you may have encountered those sign-in options where they ask you, do you want to sign in with Gmail or Facebook, right? And then you can see the next service, that's AppCheck, and this is new, and it was discussed a lot at Google I/O recently, a couple of weeks ago. So this provides attestation so that you know that the request is coming from your authentic app and from an authentic device. And then there is the Firestore database. That's what we're going to talk about today. But if you notice, there's one more database in here. There's the real-time database, and that's another database that Firebase provides. It was the initial database that they had, and there are some differences as well as some similarities between the two. Next, you can see there's extensions, and extensions is again a new thing that Firebase offers. And also we have hosting, functions, machine learning. There are a ton of these services. And next, you can see release and monitoring. So you may have used Crashalytics, performance, so that you can see how your app is doing, where it's crashing. There's also test lab and app distribution. And the list does not end here. There's also analytics and engagement. So you can do things like A/B testing, remote config, app messaging. There's a lot that Firebase can offer. So it's an amazing toolkit to support your app dev journey. So now let's look at database. So there are two types of database services. There's the relational database and there's NoSQL. Relational database is schema-based, and I'm going to talk about what a schema is in just a bit, but it is typically implemented as tables. With NoSQL, on the other hand, we have non-tabular formats, and I'll give you some examples of those formats. But I mentioned two different database services under Firebase. There's the real-time DB as well as Firestore. Both of them are NoSQL DBs. So you may be familiar with relational database, but let's just have a quick refresher. Now, in a relational database, it's a table, right? Like a spreadsheet that you have with Excel or Google Sheets. And the important thing here is it is schema oriented, which means that it's really important when it comes to the columns, like what the columns are going to look like, which column will serve as the primary key, what are the relationships between the tables. So let's look at an example. So this is a table with the list of some of my favorite TV shows. And here you can see various columns. And we can use the first column, the series ID, as the primary key so that I can uniquely identify each of these rows, right? And I can have some constraints. I can say that, the title should always be a string. There should be a certain length for this title. It should not be allowed to be null. And similarly, I can say that, the number of seasons should always be an integer. And in that way, we have a schema established. I can have another table where I can track the different episodes that I have watched for these TV series. And I can use the episode ID as the primary key. Now, to create a relationship between the two tables, I can use the series ID from the first table. And I can use that as a foreign key. So think of it as a borrowed column from the first table. And this can help me create a relationship. Like in here, I can use the first row is linked to the first row of the other table because of the series ID, because they have the same series ID S123. And so is the case for the next episode as well. And now we have a relationship, right? And here are a couple of more examples. So you may know that the query language for relational database is SQL, or structured query language. And as you can see that there are so many constraints around the schema as well as relationship, this can get really resource intensive when you try to scale. So if you're trying to scale, you would need to invest in your host machine to improve the processing power. On the other hand, with NoSQL, we don't have this rigorous scheme-based approach with all these constraints. So scaling is easier, and you can scale with a horizontal scale approach, which means that you can distribute the database across several machines. Here, the focus is on speeding up queries, and you have a flexibility to add fields more easily. So there are various ways to implement a NoSQL DB. You have the key value based approach, and with the key value based approach, there's a key and a value. And an example of such a database is Redis. There's also the wide column based approach where not all rows need to have the same columns. An example for this is Cassandra. There is the graph-based DB where there are entities that are nodes with static relationships, just like in social networks. Neo4j has this approach. And then we have the document-based DB, where it's like a JSON-like document. MongoDB is such an example, and so is Firestore. So let's do a quick comparison of relational database versus NoSQL. As you know, relational database is table-based, it is schema-oriented, and structure really matters. So it is usually implemented as tables like we saw, but NoSQL, on the other hand, is schema-less, and it has a non-tabular format like in these different scenarios that we just saw. So the advantage of this is there is a flexible structure, but don't think that relational database is, still not useful. It is very useful. It is very powerful, especially when it comes to queries. Queries here are more customizable. So if you're not sure of the kind of queries you need and you need more options, then with relational database and with SQL, you can run a lot of different types of customizable queries. You can add filters, you can use where clauses and match different string patterns. NoSQL, on the other hand, is useful when you know the access pattern, which means that you know what kind of queries you plan to run. And the benefit is better performance and lower latency. And as we discussed, a relational database scales vertically, whereas NoSQL scales horizontally. And something useful that I came across on the net was you can think of this as when you're scaling vertically, think of stacking, floors on in an apartment building, whereas with horizontal, think of it as creating new houses in the neighborhood. So this would be a quick animation to demonstrate that. Now let's look at the key features of Firestore. So Firestore is a JSON-like document, right? And there are, keys and values. So, you can have the name, you can have age, and you can have the value, right? And you can also have something a bit more nested, like in this case, you have address, and address has various fields inside it. So the documents in Firestore are JSON-like, but that's not all. Now with Firestore, it is a collection of documents. So keep this visual in mind. Think of a folder with various files, okay? Firestore is a collection of documents. We'll go through an example now. Let's say I have a student called Kelly, and I have a document on the student so I can track information like her name, her address, her major, right? I have another student called Raj, and again, I have some basic information. And now, because it's a collection of documents, you need to place these documents inside a collection. You cannot just have these documents hanging about. So we're going to place them in a collection. And I'm going to use this color scheme throughout my presentation. I'm going to use pink for documents, yellow for collections. So now, at the very base, I have this collection. And being students, they are, obviously enrolled in courses. So I could have documents for the courses that they are enrolled in. Maybe Kelly is enrolled in a couple of courses, and I can have documents on each of these courses and track things like the course code, the course name, the professor, and Kelly's document can point to the collection of these documents. Similarly, I can have Raj and his document point to his own collection of course documents. So you can see that now we have a hierarchical structure because now we have another level, right? And we can go further with this. Maybe there are various submissions that you need to do for a course, and I could have a document to represent each of these submissions. Like the algorithms course could have its own submissions, so would be the case for the other courses, right? And now you can see that it's getting pretty hierarchical, and you're getting some idea of what a Firestore database would look like. So as we discussed, Firestore is a collection of documents. And if there's anything I want you to take away from today, I want you to remember that Firestore is a collection of documents. That is, it always begins with a collection. And you can have a document point to its own subcollection if you want. The document, of course, has its own data as well. And this is the alternating pattern. It's collection of documents, again, collection of documents. Now, you start with a collection at the very base, but you could have more than one collection as well. I can have another collection at the same level. So maybe the first collection is for my students, and the next one could be for the faculty members, right? And when it comes to documents, apart from having data, we know that they can also point to a subcollection. I could have these documents point to more than one collection too. So you can see that Firestore is pretty flexible. And when it comes to these documents in Firestore, you're retrieving the entire document. That means that if you want to get, just Kelly's grades and you don't care about her address and the other information, you don't have that option. You have to retrieve the entire document. So keep that in mind when you're planning your database. And also there is a limit. The size of the document should be less than 1 MB, and the number of fields which should be 20,000, which is fairly reasonable considering that we would usually have a lot of text data. When it comes to queries, they are shallow and not like the song here. But when you run a query in the database, and let's say you want to get Kelly's document. So when you ask for Kelly's document, that's all you're going to get. You're not going to get any of the things that are in the other sub-levels, like in the other sub-collections. So when I ask for Kelly's document, I'm not going to get any of the information about her algorithm scores or her assignments or any of that. I'm just going to get Kelly's document. And another thing I want to mention is security rules. So Firestore has a part of security rules to control access. So you can create rules around who can access which documents and which collections. So even if there's like this Snoopy professor who's trying to figure out what his student, got in another course, you can stop him from doing that, right? So you have access rules, and you can also use security rules for creating validation rules. So for instance, if you consider grades are numbers that could be a percentage, like between a 0 to 100. So you can enforce that it should always be a number between 0 to 100 using security rules, so that even if your student is super smart, you still cannot give them like 200%. This is beyond the scope of today's talk, but I just want to mention it because it is pretty important. So now that we have this basic knowledge, let's apply this. So I love learning outside of work, and I'm sure you guys do as well. Like here we are attending this Connect Recharge conference, and I love going for other meetups and workshops as well. And then also I like, learning through doing, creating my own projects and building my portfolio. And I just want to mention that right after today's talk, the next session is also on side projects and how you can use that for your career. So do check that out. It's right after this session. And then then of course you need to keep yourself updated. You find yourself learning through books and courses and articles, right? And if you've used the networking feature today, you're probably making some connections, and that's also part of your career building. Now, this is a lot. I get overwhelmed in the process, and I end up looking pretty stressed like this. So I thought, okay, maybe I can build an app that could help me, track all these activities, because I'm an app developer. Why not, right? So let's look at what the database would look like for this kind of an app scenario. So we know that Firestore is a collection of documents. So let's build this collection of documents. Let's start with our base collection, and that could be the activities collection. So we start with the collection, and inside that we can place various documents. So I can have a document for for a meetup that I attended on Android, right? Maybe I attended a workshop on blockchain and a course for Firebase, as well as I read a book on SQL. So now I have my base collection established. So let's look at one of these documents. I can add some data, right? I can keep track of the name of the activity. What was the type of the activity? Was it a meetup? Was it a conference? Was it an online course? And I can also have other relevant information, like in this case, today's event is organized by Women Who Code. Maybe I have an instructor for a course, the author of a book, all of that information. And I can store most of this using strings, right? I could also have the rating so that I know how much I enjoy the event. And I could use that, I could store that as an integer, and I can use security rules to enforce that, again, this is a number between 1 to 10, right? So now let's run a query for such a database. So to do that, you would first need to create a reference to Firestore, like in here. And then once you're at the right database, then you can point to the collection, that base collection that we have. Here, the collection is activities, so I'm pointing to that. Now I can run a query and say, okay, so how many of my events are equal to meetup? So I'm using a where clause. I'm saying activity type is equal to meetup. So this will help me find all my events that have this condition met. Another simple query that I can run is I can say how many of my events did I enjoy? And if my enjoyment threshold begins at 7, then I can say, okay, so where field rating is greater than 7. So that would give me all the events that match this condition. Now let's talk about executing queries. So when it comes to executing any of these queries, there are two ways to go about it. One is you can just run the query one time and leave it at that. So your code snippet would look something like this. Don't worry about all this inner code, but just try and understand the basics. Here we're trying to get the documents, and inside, when you do get documents, you can get access to the snapshot as well as the arrow. Inside the snapshot is where you retrieve the documents, and then you can decide what to do with it. You can display it on your app or print it or whatever, right? So here I have access to the keys and values, and I can display it. Another way to execute queries is using the listener approach, which means that every time your database changes, the logic gets triggered. So the code snippet would look something like this. Now, compare these two code snippets and try and identify what is the difference between these two. If you look closely, there's just one difference, and that is the function that they're using. Here it's get documents, and for listener, it is add snapshot listener. So that one function itself can help you make your change your approach. And hopefully you can see that things are fairly simple. Now, if you want to, keep track of the various skills that you enforced, like today you're learning, a bit of Firebase, a bit of Firestore database. Maybe you want to track all of those skills, right? Like as different tags. So I can store them as an array. Like in here, it's Android, Kotlin, and Java. And I can even run a query so that I can find out how many of my events did I, use either Android or Kotlin. So we can use array contains any. So far, hopefully it's been straightforward. And now let's just look at what the Firestore console would look like at this point. So I'll just show you a sneak peek. So as you can see on the left side, this is the different services that there is in Firebase. And since we have Firestore database clicked, that's what I see here. I can see my current database. And at the very root, we have the activities collection. And inside this collection, I can have multiple documents, right? If I want, I can also create another collection right here. And if I open any of these documents, then I can see the data that is inside it, right? Like keys and values. And also when I'm at a document, I can also have them point to their own sub-collections, like in this scenario. And we know that sub-collections can, again, have their own documents. Those documents can have their own data plus their own sub-collections, and it can go on, right? And as you can see, there are other things in here. You can see the rules, like the security rules here. We have indexes, and there's composite and single index, and that's what I'm going to talk about next. So what is an index? So an index is a data structure that is a sorted list of all the values of your database. So it has the values as well as the location of the element. So if that's something a bit confusing, just think of those academic books that you use. You know how they have the index at the very end of the book. Similarly, that's how Firestore also maintains an index. There is a sorted list. Like, let's look at this example. Here is an index from the book Sapiens. If you're familiar with that book, it's pretty chunky. And there are various terms in here, right? And all these terms are placed in an alphabetical order, so that means it is sorted. And it also gives you the location. It tells you where you can find these terms in the book so that you don't have to scan through the entire book looking for those terms, right? So it has the page numbers and you know where to find it. So for example, the word famine could be at any of these pages, and now I can save time instead of going through the entire book. So same way, we have Firestore creating an index for us. It keeps all these different fields in a sorted manner, and it also keeps track of where they can be found in the database. So keep in mind that Firestore creates an index for almost all your fields automatically. And if you want, you can tell Firestore to create exceptions to that. But thanks to this auto indexing, we are able to retrieve data very quickly. So, the queries that we just ran, like we said, okay, activity type is equal to meetup. That was very quick for us. Even the rating is greater than 7. Because these are single fields, so it creates these single indexes behind the scenes. And one thing that you might note is that when you try running queries, you're trying to store data. When you do write queries, it might take a little longer because it's saving all this stuff inside the index and these additional data structures. So it might take a little long in terms of storing, but their priority here is reads over writes. So the retrieving part is so much quicker. And if you think about it in apps like IMDb, where as a user, you're more likely to, just retrieve information more than actually, write, then it really makes a lot of sense. So these queries were easy for us to run thanks to auto indexing. And also, if you want to try something a little bit more complex, like let's say you want to find out how many meetups were organized by women who code, then you can chain your where clauses like in here. And because both these fields, the activity type as well as the organizer, both these fields are in their own index, and we're asking Firestore to do an equality comparison, Firestore is able to intersect the two indexes very easily with their own algorithm. So it will allow you to run this kind of a query if you use both equality operators. But if you're trying to run a query like the one here, where I'm saying I want an activity equal to meetup and rating greater than 7. So here I'm using an equality operator as well as a range operator, the greater than operator. So here for Firestore to intersect is not possible. And if you think you're going to need such queries in your app, then you can create an additional index which concatenates these two fields. And that kind of an index is called a composite index. So fortunately, it's pretty simple to create a composite index. All you need to do is hit this query once from your app, and it's going to scream at you at first. It's going to say you're not allowed to use this because you need to create a composite index, but it will also give you a link. You just click on that link and it generates the query for you. So, again, Firebase really helps. But depending, another thing to consider is that there is a limit to this, and the limit is 200. So that's another thing to keep in mind. So now let's talk about another scenario. Hopefully you guys are, tweeting about the event today. And if you find yourself posting on social media like me, you might want to also consider storing the write-up information in this database. So we can store it as another long string. Like in here, I can have one long string for the event that I attended. If I want, I can even store it as an array of strings so that if I have multiple write-ups, so that I can have one for Twitter, one for LinkedIn, which might be longer, maybe one for Medium article, and so on. So that is definitely one way to go about it. Let's look at another way of storing write-ups. So I can also store write-ups in a nested form. Like in here, I can have other associated fields like the date that I posted it on, the medium that I used, which social media platform I used, right? And I can, when I use this nested structure, it is called a map in Firestore. And if I want, again, I can store this as an array of maps, right? So this is another approach, but I want you to consider a trade-off here. So let's say you're building an app which displays all these different activities. And here I'm storing, the basic information. I'm displaying the name of the event and the type and the organizer, right? Now, as a user, I'm only seeing some of the fields. I'm not getting an entire description. I cannot see the write-ups unless I click on one of these rows, and then I get all this detailed information. Maybe it's really long with the write-ups. Maybe I end up scrolling, right? But if I, as a user, do not, click on every row, then I'm probably downloading more information than I need, right? If I have a lot of write-ups, then I'm probably downloading more information. And if I don't want to do that, I want to avoid doing that, then I could restructure my database. So to do that, I could store my write-ups as a sub-collection. I can place them in their own collection of write-ups. So that would look like this. So I could say, okay, so each of my write-ups could be in their own documents, and I can place them in a sub-collection like this. So the database so far would look like, you have your activity documents, and each of them point to their own sub-collection of different write-up sub-collections, right? I could even have some activities which may not have their own sub-collection because you don't necessarily have a write-up for everything that you attend, right? Now, there's just one more thing to consider. If you run a query and say, how many of these events did I post about on Twitter? Here I'm trying to span across various sub-collections. I'm trying to combine the various sub-collections, even though Firestore is actually creating an index only for the sub-collection separately. So if you find yourself in this scenario, in this situation, then you can use a collection group query so that Firestore can combine the index for all these different sub-collections. So keep that in mind as well. And now let's look at one more scenario. Let's talk about, when you go for those events and you make new contacts, like the in-person events, which are now kind of, they're getting back. You might enjoy the technical content, or if you're like me, you might enjoy the food. But of course, we do meet new people and you might want to remember them. So let's see what we could do to store information about them in our database. So one approach could be to store them as a sub-collection. So just like we did with the write-ups, I could store information about these new folks that I meet and place them in their own sub-collection according to whichever event I met them in, right? So that is one way to go about it. But you could also consider another approach. You could use a top-level collection, which means that I could place the new folks, the new connections that I made in a collection at the same level as my write-up, as my activities. So let me just show you how that looks. So I could, again, start with my activities collection like we started in the beginning. And each of these activities can point to their own write-up collections like here, right? And then I can have another collection of these people at the same level as my activities. So now they're at the top level, right? And if you're trying to figure out which of these two approaches to go for, then you need to figure out what kind of queries are you likely to run. So in this scenario, the advantage is that you can run a query for all your connections independent of the activities, which means like if I want to find out how many people that I have met through all these different events, how many of them work for a certain company, then I can run the query right across this collection instead of having to do a collection group query. So you can, decide these trade-offs and figure out which approach works better for you. And of course, you can go a level beyond this and, add more information about these contacts. So this is what our final DB would look like. So wrapping up. So as you saw with Firestore, the beauty is that you can leverage Google Cloud services. They take care of all the backend for you, like scaling and setting up servers. And it has a robust client library. And they offer security rules for access. It is near real time. And they also have a strong reliability. And it's very easy to set up. Plus, there are other features as well, which I didn't talk about just yet. Maybe that's for another talk, but they have offline support. They also offer transactions and pagination, and it's pretty flexible. And it supports an iterative approach because that is something you probably want in your app, right? You want something where you can easily add new fields, and of course, since we are using Google Cloud services, you can create apps that synchronize where users can collaborate with other users. You can have an app that can be used on multiple devices on the web as well as on mobile devices and tablets. So basically, I feel with Firestore that I'm having my cake and I'm eating it too. So here are some of the references I used. I mainly looked at the main documentation and the videos that Google offers for Firestore. And I highly recommend that as well for you guys. And yeah, that's all. Thank you so much. Any questions? Thank you. Yeah, let me know if you guys have any questions. I'm looking at the chat if there is anything. Looks like you guys understood everything. So yeah, if you do have questions, even later, you can reach out to me.
So, thank you, Navati. That was an amazing presentation. You guys, we still have some time left. So, if you guys have any questions, please feel free to leave them in the chat. Um,
Yeah, and definitely check out the
a
next
lot of
session as well.
people, yeah, a lot of people love the visuals though, and I totally
Yeah.
agree with that. I think I think it just makes it more interesting. um, the graphics, it definitely makes you pay attention easier and understand it as well. It makes it totally clear. I loved it.
Thank you so
Absolutely
much. Yeah,
love
I
the
love learning
slides.
like that. I'm so guilty of using, emojis and stuff when I'm learning or making notes as well. Like it motivates me to learn. So I'm glad that worked for others also. Yeah, cool.
Looks like there are not any questions from the audience. So I mean that speaks a lot about how well the presentation went. Um,
Awesome.
so yeah, thank you again, Navati, and thank you everyone for joining in.